Good morning, viewers. Today, in the program Promises of the Past, we are on the beach in Badalona. Did you know that water covers 70% of Earth's surface? This percentage indicates that water is an almost inexhaustive source of matter. Well, today we are going to welcome an Australian scientist who is very relevant to nuclear fusion, and this is usually carried out by the collision of hydrogen nuclei. We can obtain hydrogen by hydrolysis of water molecules, so we won't have any problems with hydrogen deposits, because we have almost unlimited water. Having said that, we are going to move on to Mark Oliphant.
Thank you very much, Jane. I really appreciate your overcoming.
Your overcoming is my pleasure.
Thanks to your explanation, I really understand all about this.
Thank you, Mr. Oliphant. Hydrogen is a very interesting atom. It is made up of an electron orbiting a positive nucleus made up of a proton and a neutron, and it has several isotopes. Doesn't it?
Oh yes, it consists of three isotopes, protium, deuterium and tritium.
As I understand it, you are known for discovering tritium and helium-3. Could you explain what these isotopes are all about?
Oh, of course. Tritium is an isotope of hydrogen that consists of one proton and two neutrons. Helium-3 is an isotope of helium that has two electrons orbiting a nucleus consisting of two protons and one neutron.
Well, interesting terms are coming up. Tritium is very important, as we need it to carry out nuclear fusion. How did you discover these isotopes?
I was lucky to get a fellowship as an assistant to Mr. Rutherford at the Cavendish Laboratory at Cambridge University in the UK. Rutherford and I worked on recognizing experiments of this laboratory, and we built a positive ion accelerator and a cyclotron. That machines accelerate positive particles in a circular trajectory at the energy of 600,000 electron volts.
Amazing! And how do you use these machines?
We use these accelerators to fire heavy hydrogen or deuterium nuclei, which have a proton and a neutron. We collided these deuterium nuclei with isotopes of hydrogen too.
Well, and which conclusions did you come at?
We discovered new ions and isotopes, namely tritium and helium-3. We could also observe that when the two nuclei react with each other, particles with an energy higher than the initial energy of the process were released. Some of this energy was released from inside the nucleus, and we concluded that this was due to nuclear fusion.
That's a really good news.
I don't think so. The first hydrogen bomb, called IGFAE, was created with nuclear fusion.
Don't take care about it. If the nuclear fusion hadn't been discovered, the ITER project would not have come true. Nuclear fusion has a lot of benefits. It doesn't generate radioactive waste, and we can obtain more energy than what we use to start the reaction.
Oh my god, I didn't know that nuclear fusion had improved so much.
Yeah, so don't give up, Mark.
Thank you very much for showing me that my work has not been in vain. I can waste my time. Now I must get back to my time because I have a really important meeting at 1977.
Okay, Mark, so goodbye.
Goodbye, Jane.